Another contract in the voting folder is the group contract. And actually there are two group contracts. There is group, there is delegated group. And actually both of them use the group checkpointing, which I'm going to get a bit faster with. So the group checkpointing uses these checkpoint structs that have from time and value, similar to the checkpointing in the token token. And the implementation is pretty much the same. We have the new checkpoint for the first one. Then we have this get last checkpoint function, which again gets either the last checkpoint or returns the new checkpoint. We have the get checkpoint function, which goes again with binary search and finds the checkpoint on the left of that time. Then we have the push checkpoint function, which takes the current time and inserts a new checkpoint with that time, or returns the current checkpoint if it's already for that time. And again, the current time and convert time functions, just to copy the structure. And here the value is a 160-bit value. And the idea for this is that way we can reuse the checkpoint code for both group and delegated group, because addresses are actually 160 bits. And group just takes this checkpointing and is an owned contract, which again either sets its owner to the set owner or to the one who just created the group, because we don't want the group to go without an owner. And that's actually useful for when we do groups with voting, because we want the voting to be the owner of the group, but we have to create the group first, then create the voting, then set the group's owner, because it's a cycle between two contracts. And the group maintains a mapping of weights, and we have a weightf function that just gets the last checkpoint and returns the weight, or weightf add that gets the last checkpoint and returns the value. No, actually, not sure why we have two functions here. I think it's related to the delegated group. And the non-delegated group actually has always zero delegate, either right now or in the future. Those are virtual, so that they can be overridden by the other class. This is so that we can quickly make groups without delegates if we ever need to do that. And then we have the delegated group, which also takes care of delegated weights. And the delegated group again maintains list of checkpoints for the delegates. It has a set delegate function, which adds a new delegate, or updates the delegate for a member. And here we get the current weight of the member, and then we start updating weights by first reducing their weights by this weight, and then in the other direction just increasing them by this weight. And this is actually not as optimized as the code in the token. That's because the group contracts were mainly meant for testing and not as much for day-to-day usage. So it's fine if it's a bit pricier. It saves a bit of coding time, right? Though it can probably be optimized a bit, like not use calls here, but I guess directly inline them. Though it doesn't seem like it needs much inlining. It should be fine as is. And it also implements delegate of and delegate of add, so that it would work with the voting. Actually, it just needs the delegate of add function anyway. And I think there is also there is this set weight of function, which could be used for example, for adding new members. Currently, set weight of actually does not function together with set delegate of, because this sets the actual weight. It's a bit elevated by the fact that this is only to be used by the owner. But again, this saves a bit of pain when because it's meant to be used only internally. I'm not sure if this made much sense, but to quickly go over it again, very sorry about that. The group contract has a constructor which just sets initial members and their initial weights, or if you don't give initial weights, it just assumes 1. Then it sets, it has a function for setting the weight of a member. However, if that member has people delegating to them already, then the weight that is set should also include the delegated weight. So it is not meant for like wide public usage, because then it would. Then you have the weight of function, which just returns the weight at the last checkpoint, and the weight of add, which returns the weight at the given checkpoint. And the functions for delegation are just the set delegate of function, which is used by the delegate function, so we can delegate to someone. And the set delegate of function just iterates along the chain of delegates and updates the weights on that chain. Like first reduces the weights by your weight and then increases them by your weight after updating the delegate. And that's about it for the group contract.